Hey guys, welcome to Pepcoding. So in this video, we are going to discuss our new question of searching and sorting series, and the question is first bad version. So let's discuss what this question says. This question says that you are a product manager. Suppose that you are a product manager and currently leading on a team to develop a new product. It means you are working on developing a new product. So unfortunately, the latest version of your product fails the quality check. So since each version is developed based on the previous versions, so all the versions after the bad version are also going to be bad, right? Because all the qualities of my previous version are transferred to my next version also, because we don't know if it's a bad version or not. Now we didn't know. So once our version is failed, all the versions after that version are also going to be failed. So suppose you have n versions and you have to find out the first bad one which causes all the following ones to be bad. Okay, so we have to find the first version that fails the quality check. Okay, so you are given a function that is, if its name is bad version, so it returns a true if the version is bad, and it returns false if the version is not bad. Okay, so let's discuss. Suppose I have 50 versions. Okay, it means I have formed 50 versions of a product. So let's say I have first version, second version, third version, fourth version, and so on and so forth till 50. Okay, I have 50 versions. Okay, now this is my first, that is my lowest version, and this is my highest, that is my latest version. Okay, now I have to check the first version. So I say I will start in checking for my first it means I will start checking from my first version. Then I will check every version if it's a bad version or not. So I say that this is equivalent to linear search, that you are picking up every element and checking it, right? Which is not optimal at all. So even if I say that I have a low, I have a range, that is I have a low and I have a high, and this versions, the number of version are also in a sorted manner, right? So I can apply binary search here. Let's see how. Suppose suppose my first bad version was, let's say, 32. Okay, no, not 32. Let's say suppose my first bad version was 17. Okay, 17 was my first bad version. So so I calculate my mid here. So my mid will be equal to what? 1 plus 50 by 2, which is equal to 50, which is equal to 25. Okay, so my mid is here, right, which is equal to 25. So I will check if is my 25 bad. Is bad 25? Is this version bad? It will say yes, it is bad, right? Because after 17, all the versions are going to be bad, so it is bad. So my range reduces from 1 to 50 to 1 to 24, because 25 is a bad version, so all the versions after that are definitely going to be bad. Okay, so what do? I shift my high from here to here. Okay, now my high is pointing to 24. So now my low is 1, my high is 24. I calculate my low mid again, which is equals to 25 by 2, which is equals to 12. Okay, so my mid is here, that is equals to, let's say, here 12. Okay, now my mid is 12. Now my range was what? My range is from 1 to 1 2 3 4 1 to 24. Okay, it sees here, it calculates, it checks if the 12th version is bad or not. So I call is bad 12. It says no, it's not a bad version. Okay, it's a good version. Let's say it's a good version. So if it is a good version, all the versions prior to this version are also going to be good, right? Right? Because this version of mine is good. So this version cannot be the first bad version. And all the versions before to this version, prior to this version, are also not going to be the bad version. So what I will do, I will just increase my low to mid plus one, because this is a good version. So maybe the mid plus one, the element can be a bad version. So I increase my low to mid plus one. That is low. My new low is 13, and my high is equal to 24. Okay. So now my new range is in between 13 and 24. Okay. Sorry. Okay. Now I again erase this. My low is 13 and my high is 24. let's write here my low is 13, my high is 24, and my mid is going to be what? 13 plus 24 by 2, which is equals to 37 by 2, which is normally equal to what? Which is equals to 18. Okay, so here is my 18. It checks, this is my mid now. It checks, is my 18 a bad version? It says yes, 18 is a bad version. It says yes. So all the versions after 18 are also going to be bad. So I update my first bad version to 18. Prior it was what? Prior it was prior it was like 24. Now it becomes 18. Priorly I saved my first bad version to be 25. Now it is like updated to 18. Okay. Now my first bad version is 18. Now what do? I reduce my high from this position, that is from what was my high? 24 to, let's say this was my range 17. I shift my high from this position, my range was 24, from this 24 to mid minus 1. What is my mid? Mid was 18, so I come here, that is to 17. Okay, this is my high, this is my low. I again calculate my low plus high by 2, which is equals to 13 plus 17 by 2, which is equal to 15. Alright, now it checks, is 15 a bad version? It says yes, 15 is a bad version. What do you have to do? You just have to increase your low to 16, because all these are also going to be good version. So I will check, is my 16 bad version? So it will say no, this is not a bad version. So no, sorry, my low come here. Now I again calculate my mid, low plus high, which is low was what? My low is 16 now, and my high is what? High is 17. So 16 plus 17 by 2, which is almost equal to 33 by 2. 33 by 2, which is equals to 16. Right? Yeah, which is equals to 16. So I check, is my 16 a bad version? No, it's not a bad version. So I increase my low to mid plus 1. That is, my low become equal to 17. And my high was also equal to 17. Right? So it checks again. 17 plus 17 by 2 is also equal to 17. So it checks, is 17 a bad version? It says yes, 17 is a bad version. So first bad is updated to 17. Alright. And now my low become equal to my high. So I return, right? So it means I have found my first bad version. Alright, because my range is, my low and high, my range is now what? My range is only 17. There is no range. I have only one element. That this is going to be my first bad version. Okay. So I hope I was able to make it clear to you. That is, we are going to apply binary search here. Okay. Mainly all the total concept was of binary search. Only the word problem was that you have to understand that it is based on binary search. Okay. So I recommend you to try it yourself or dry run it yourself. And let's code this. That is my first latest version that is my first version was my low will be my first version, and my latest version will be equal to my nth version. All right, and I have a variable named first bad, which will store my first bad version, which is initially -1. Now I run a loop till while my low is less than and equal to my high. All right, and I will check. First of all, I will calculate my mid. In mid is equals to low plus high by 2. All right, and my answer will be there. Boolean answer is equals to if bad version is bad version and mid. All right, and we'll check if it returns true. If answer, then do what? Then store this answer in your first bad. It is update your first bad to be the mid. First bad is equals to mid, and reduce your high to mid minus 1. All right. Else increase low to mid plus 1, because it means as this is not my first version, so all the version prior to this version are also not going to be my first bad version. So increase my low to mid plus 1. All right. Mid plus 1. Mid plus 1. And then return first bad. All right. Now let's try to run this. Let's try to submit this. Sorry, it is going to be I was supposed to use parentheses here, because applying parentheses gives you the correct answer. Okay. And accepted and correct answer. So I hope you were able to understand that why am I using binary search here and what was this problem mainly saying. Okay. So I hope I was able to make it clear to you. So I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.